Thank you for coming and welcome to a whole world of MIDI. I'm going to try and talk about 5 things today, and I'm not going to make it overly technical, but what MPE is, so essentially who needed it and why it was needed and how it works and why you might want to adopt it. And finally, a little bit about what's next and implementation difficulties and what the roadmap is after MPE, because it will transpire that MPE is, like many MIDI extensions, something of a kludge. Let's get on with this. Who needed it? Okay. If you backtrack a few years before the working group really got started, we suddenly started seeing this new generation of instruments appearing where each note was individually controllable in an expressive way, which keyboard instruments traditionally weren't in the past. Guitarists had the same problem but mitigated it in different ways. MIDI guitarists, both of them. So, for example, we have that instrument, the Hacken continuum, Geo Shred, Madrona sound plane. All of these things are sort of multi-touch, but with each touch you can bend notes and change pressure or change position and alter every single note individually. And it'll become clear throughout this talk that MIDI wasn't really designed for that. As well as things photographed on a black background, there were also things made that were photographed on a white background that don't work on that slide. So, for example, we have the Eigenlabs Eigenharp Tau, the kind of magical cyber bassoon, ROLI Seaboard Grand, Darth Vader's piano, and the Keith McMillan keyboard, actual size. It's a keyboard according to his website. It had better be. Oh my God. There's that big thing called a keyboard 4, which looks a bit like a Seaboard but isn't. So there's a whole load of people who purport to make devices that either are MPE or support MPE or describe something akin to MPE. All of these people, basically, the MIDI Association in the middle, because we're working with them to ratify a specification that's an extension of MIDI officially, which is very important for getting large companies, particularly Japanese companies, on board, but means that everything takes another couple of years to make real, because working with any kind of standards organization is fairly bureaucratic and slow by definition. So lots of people, as the logo that's hard to decipher there is Cycling 74, makers of Macs, and everybody else I think is fairly self-evident. I mean, Open Music Controllers is a sort of fan club that make a PCB, and everybody else is a sort of established legitimate company except for Apple, who I don't know who they are. Okay, so back before MIDI, MIDI became a standard. I think the first MIDI product was released in 1983, so this thing here, the CS80, was released in 1976, before most people in this room existed and before MIDI existed. The one thing it was able to do that nothing else was really able to do at the time was offer polyphonic aftertouch. So every single key had a sort of 4-sensor arrangement, and the harder you pressed it, the more you could change the sound. And it wasn't just a kind of big resistive strip like aftertouch is these days. Every single key was individually controllable. One of the things about coming up with a standard is that it tends to adopt things that are already there for no other reason than they're already there, and things that aren't already there don't get into the standard, and it means eventually people stop thinking about what should and what shouldn't be in there. So if you look at the way that standard MIDI keyboards are, they've always got a pitch and a modulation wheel on the left-hand side. No one really questions that, why you need 2 controls, why it has to be those 2. They're just there because MIDI can deal with them, and they're there because everybody else puts them down, and they're there because they've kind of become a de facto standard about how you build keyboards. So eventually the industry ends up taking the electronic specification of the user interface of a protocol that everybody uses as basically the functional specification of whatever it is they're going to make next. So MIDI can, by some strange coincidence, handle polyphonic aftertouch very well, and there's a message that does it. Hurrah! And there the good story ends. If you want to do pitch bend, you're stuck to using one of 16 channels that are available in MIDI to do it, which means you have 16 separate pitch bend messages, and then that's it, and you can't really do anything else with pitch. And it's not controllable per note on those channels. Nothing else is controllable per note on MIDI. So we are sort of stuck. And in order to start having these expressive instruments talking to each other, talking to new generation synthesizers, we either have to throw MIDI away, which is a terrible idea because there's 35 years of work and science and music invested in it, or we have to try and embrace what MIDI can offer and find a way of bodging whatever we're trying to do onto the spec. So we need MPE. MPE stands for MIDI polyphonic expression now. The first stem was multidimensional, and we decided that that was too many syllables. And so we have simplified the name slightly. and it's note per channel MIDI. So every note you play gets put on its own channel until you run out of channels, and then you have to start making some compromises. So you can play and individually control 16 notes at once, and beyond those 16 notes, well, we're hoping nobody has to play and control 16 notes at once. But that's the limitation of MIDI. Note per channel MIDI has sort of existed for other purposes, fairly esoteric ones for a little while now. And there was a sort of gentleman's agreement about how it worked, so that's the end of my talk. Thank you very much. Although, of course, blatantly it isn't, because I gave my game away at the beginning. So why it was needed. Why do we need MPE when note per channel MIDI sort of exists as a de facto standard? There's a truism about MIDI that it kind of works on selected things. It's very, very good at note on and note off, and the use cases that 90% of people want. And beyond that, the support is fairly patchy. What doesn't work about MIDI when you're trying to do note per channel stuff? Omni mode, where you're receiving and playing every channel, sort of works weirdly, or it doesn't exist at all. Either an instrument doesn't handle mono mode, or it just merges all the channels together into a single kind of channel and pretends everything's on channel 1. So when you start trying to control notes individually, you can't. But it's a sort of fairly minority use case, and it works for most people, and then Omni mode just functions weirdly forever. Pitch bend range changes for each preset. So typically on a synthesizer, they don't expect pitch to pertain to a calibrated axis like it does on the keyboard, where you send a specific pitch bend message out and go, OK, this is pitch bend up 1 octave. Every time you change a patch, it tends to change the pitch bend range to whatever sounds good on that patch, or 1 octave, or a tone, or a fifth. And people get creative, and it means that things like a keyboard decalibrate every time you change patch, because it doesn't know what the pitch bend range is it's controlling. So that can be a problem with many of the instruments of today. Notes might not start properly. If you've got many dimensions of control, pressure and Y and X and so on, there are initial conditions to the way a note starts, which depend on the way you're pressing it. And you have to kind of send that information before the note on message starts. Otherwise, you'll end up starting to play the note and then having to slew very quickly towards whatever the values are you're about to input. And the transition noises are audible, and they're very annoying. So there's a sort of information that comes before a note plays is important in note per channel MIDI, and not all synthesizers are aware of that because they've never tested to it. Polyphonic aftertouch is rarely supported because it's never really used, and if channel pressure is good enough for most people, those messages are just masked out and never see the light of day. I worked for Novation for 6.5 years, and I designed synthesizers, and I never put polyphonic aftertouch into anything. And no one noticed. That's fairly typical. No one will notice until you're trying to make a new generation instrument play with it. Editing MIDI streams is a pain. Note per channel MIDI goes into a DAW, and then you want to start trying to draw curves over notes for expression or change pitch bend, and you find the data goes all over the place because DAWs weren't really attuned to this. What else? Oh yeah, this is a problem we did actually manage to solve. If you're trying to do anything if you're trying to build a synthesizer in a musical instrument, you kind of start with embedded Linux, because then you can have a complex operating system managing all your stuff, and you can do audio and processing, and you can write it all in C++, and everyone is happy, and you don't have to fiddle with DSPs, and I'm running out of breath. But the trouble with embedded Linux at the time is that, again, it wasn't tested for high traffic. As soon as you started to play with anything that was near the rate of DIN MIDI, so about 3 kilobytes a second, it would start dropping packets, falling over. There were memory allocation problems, and stuff would go missing. And that was the same if you were doing sysx upgrades or anything at all. We found that, and Felipe fixed it, and we love Felipe for that. But at the time, that was just sort of typical of people just not testing stuff for this sort of application. Oh, Ableton, yeah. Ableton pretends there's only one channel in its implementation, so everything you play gets folded into one sort of meta channel, and it just can't do all this at all. I did actually say, this did actually say WTF Ableton before today, and I've edited this talk because I've since spoken to somebody at Ableton, and apparently there are ways of fixing this upstream before it gets in, if they change their note model and start revising it, and I can't say whether they are or aren't working on that, but I'm sure it's giving them plenty of headaches. So something might happen, I don't know, and I don't work for Ableton, so I'm not going to promise anything, but it's certainly something they're aware of. So heal the world, make it a better place. For you and for me and for standardizing pitch bend range, that's the first thing we need to do. If anything supports MPE, the pitch bend range has to do two things. So firstly, it has to not change unless you tell it to. And the second thing it has to do is obey registered parameter number 0, which is a long-winded standard MIDI way of being able to set pitch bend range remotely. So if it can do those two things, then it's already beginning to support MPE. Quite a lot of synths don't deal with RPNs very well or at all, so that's one thing. Specify control the numbers for extra dimensions of control. So if you have a y-axis, and many instruments do, that is now controller number 74. We've done that. You can go home now. Reserve a MIDI channel for global data. So things like pedals, things like master pitch bend if you're playing an instrument with a whammy bar on or something that changes pitch over all the things. All notes off messages, that kind of stuff. There sort of needs to be one channel set aside for broadcasting all that. Otherwise, if you start sending it on all channels that are active, again, editing becomes a pain. If you want to take the sustain pedal out, you've got to do it 16 times. Use channel pressure, not poly aftertouch. The reason being, channel pressure is a better understood message. The two things would be redundant in MPE, so we decided to get rid of poly aftertouch and not support it. Reserve it for future extension based on the fact that a lot of synths already just don't do anything with it anyway. So, channel pressure. Convey controller codes courteously. Sounds fairly sensible, doesn't it? I can't remember what I was trying to say there, but I'm sure I will at some point. Can you tell this talk is under-rehearsed? Because I certainly can't. And it has to be able to work in mono and poly modes. The reason for this is guitar controllers. We took this spec to MIDI Manufacturers Association at the last general meeting, and a couple of people came up to me after and said, you know what would be really great? Guitar controllers, because we've got a few of those, and we say how they should work, and no one's really interested in guitar controllers because it's such a small market. So can we fold our use case into yours, please? And we said, sure. And it just means that you have to be able to support a mono mode as well, where each of the channels plays as a separate mono instrument rather than the polyphonic one. So if you have a guitar, you have 6 strings, those are 6 channels. So as soon as you start tapping a different note, the note stealing comes into effect and the old note is killed or portamentoed or something, but it handles that mono situation gracefully. Don't leave hanging notes, so support all sounds off, all notes off, all of those MIDI messages, because if you're changing configuration halfway through a sound, then you can leave hanging notes in MPE, so respect those messages. And finally, standardize the definition of channel ranges. So MPE has 2 zones. So in the same way that MIDI has 16 channels and you can have 16 different instruments controlled, MPE has 2 zones. So you can have 2 different sounds controlled, or you can plug 2 MPE devices together and have each one on a different zone. One grows up from channel 1 and the other grows down from channel 16. But the way that they're defined and the way the channel allocation works is standardized now with another registered parameter number. So these are the things that we all need to be able to do to speak a sort of lingua franca and get on with one another. Now, a bit about how it works, delving into specification. Okay, this is what you have to do, and I'm going to just stand here for 15 seconds while you ingest the flowchart. The thing about the MIDI Manufacturers Association is if a spec is under development, they won't let you see it unless you're a member of the MIDI Manufacturers Association. It's a little controversial, but there you go. So what's available online is an old version of the MPE spec before it became part of the MMA remit. And that's still stuck up there because no one's demanded that I take it down. But it's a little bit out of date. So read that by all means. If you're not if your company isn't a member of the MIDI Manufacturers Association, subscription costs about $500 a year for a small company and gets bigger. Otherwise, if you Google MPE spec, Roger Lin's article comes up, which is a fairly good summary of pretty much what I'm going to talk about. If you do have access to the MPE spec, and I think pretty soon it might well be published anyway, I'm hoping it'll be ratified soon. If you do have access, go and have a read of it. And otherwise, there's a Juice MPE module that does it all for you, and it's kept up to date because we are members of the MMA, and you could just use that. I think Timo wrote most of it. He's pretty good at coding. Here's the MPE spec anyway, so I've just broken all of their rules. And just a little bit about sort of how it's put together. I'll talk my way through it. So it's not particularly demanding. The first 5 pages are just sort of front matter that they make you put into a specification that tell you nothing. Table of contents, legal disclaimers, something else, version control. This bit, page 6 and 7 explain the rationale of MPE, so I'm giving it away now. The next 3 pages are about allocating channels and how the registered parameter number works so that you can set up these zones and say how many channels you intend to use for notes. Pages 12 to 15, there are certain controller messages that only work per note control under MPE. And there's certain things that only really work, make sense as controls on master channel. So for example, a sustain pedal, no one's going to produce an instrument where the sustain pedal is controllable one note at a time, because that use case doesn't make sense. So we say there's an understanding that you're only ever going to send a sustain pedal on the master channel to control everything at once in a zone. Similarly, control 74, y-axis, we're never going to send that on the master channel, so it's just going to be available per note. So it's a bit about defining, limiting scope, so that when you're writing an implementation of MPE, you don't have to consider everything agglomerated together in a really messy, horrible way. And there's only a few controllers that will have to be on both scopes, such as pitch bend, because you want to control pitch on every note, but there are some instruments that have a global pitch bend as well. Hints and tips for implementers. They're quite interesting, and I'll get to some of those in due course. But there is a craft to implementing MIDI well, and MPE is part of MIDI. Those are snags that people who wrote the spec found when they were implementing it. And those are worth reading as a programmer. And finally, appendices, example code. One interesting thing is that MPE is now already part of OS X, and the constant supports MPE as part of the audio unit library, so you can actually support MPE using your standard off-the-shelf Xcode, which is a sort of very, very nice thing to be validated by Apple. And finally, handy summary table. Handy summary table. Handy summary table. And a little bit about the sales spiel and why you might want to adopt it. So it is still MIDI. We're throwing nothing away. It's just good MIDI, and it's a standard practice, and it's not really adding very much except this single RPN message to control the number of channels. You can have it today. It's testable. There are some suggestions for unit tests in the MPE spec. What we don't have, but we'd quite like, is an Android app with some test facilities available. And I think somebody was working on that, but I don't know if it's seen the light of day yet. But there are ways of testing that your implementation is nice and plays nicely. And the unit tests are fairly obvious because the specification is quite tightly written. The user experience is much better than note per channel MIDI without this stuff. When we were starting out as ROLI, we had to write this thing called polythrough. And the way that you would make your thing work with a non-MPEware plugin is you would run polythrough, and that would secretly start several instantiations of whatever plugin you had, and each one would be given a channel, and that would stack them up. And that was quite a sophisticated piece of juice that did Jules's head in, but that kind of kludge was the only real way we could make things work. The thing about MPE is nothing in MIDI just works. Nothing is truly plug and play. But this is as close as you're going to get, and the user experience is a whole lot better than what you would have otherwise. Leading edge practitioners own websites, which is another way of saying hipsters blog. So the people who use futuristic equipment are great advocates for it. So people who use instruments write happy blogs about them, and people who use keyboards write crazy happy fanboy blogs about them too. And there gets a lot of excitement out there if you're part of that, and if your soft synth supports MPE, or if you have an instrument that supports it. MIDI guitarists can use it. Well, there aren't many of them at the moment, but you know, they might. It's been 30 years, so they might eventually catch up. The experience of MIDI guitaring, I'm a keyboard player, but I'm told the experience doesn't suck so much anymore. And the reason why it started so slowly is because the experience used to suck. You had buttons on the fretboard, and you had buttons where the strings were, and it was horrible. And now it's a bit like actually playing a guitar, but no one's interested, and they think it's a bit naff. I think guitarists are even more conservative than pianists. A lot of Indian and Middle Eastern musicians out there. So, for example, A.R. Rahman, the famous Sufi musician who's bigger than Elvis and the Beatles, but only in India, endorsed this and uses it a lot. And there are a lot of Middle Eastern musicians. We have customers in Lebanon, for example, who are quite well known in the Middle Eastern music field. They like this stuff. That opens up whole new markets, because they don't play 12 tones in an octave. They like to mess things about a bit. They have their own scales, and they love these instruments. And it just opens up the whole Middle East and opens up India as well, and makes people in those countries a lot more interested in what you have to offer. Here we go. So this, in case you didn't know, is a Seaboard Rise, and this is a demo that probably won't work. But I just wanted to explain a principle about channel cycling, because it's one of the implementation details that's probably non-obvious, but a little tricky. And if you read the spec at some point, it will tell you how to deal with this kind of thing. Ooh, that looks promising. So apologies for the smallness. This is a sort of factory test thing that we have. But essentially I'm pressing notes now, and the little numbers inside and the colors tell you which channel it's being allocated to. So every time I press a note, it's being given a new channel. One of the things that MPE-aware synthesizers aren't good at is stacking notes. So when you play the same note, it has to be in the same channel. If you keep reallocating channels to it, the notes will tend to stack up, and one note's release tail and another note's attack will coincide, and it will sound rubbish, because that's not how instruments work. If you're beating a drum, the last drum sound stops when you hit the drum again. If you're playing a piano, the last note stops when you hit one again. That's how instruments work. So every time you play a note, you want it to be allocated to the same channel, except this is C. I'm going to put this down because it's a two-handed operation. C being allocated channel 12. And it's always being allocated channel 12. If I bend it away from C to G, it's still actually C because it's just C with pitch bend on it. Then actually I can magically press this note again. And you can't assign it channel 12 because you've assigned them both channel 12. You can't have the same note, the same channel number on a MIDI stream, or the old one will stop. So you've kind of got to make sure that whenever you do that again, you're allocating different channels. It's just one of the stupid things that you have to do in order to make it work well. So that was my very quick demo, and I'm surprised it worked as well as it did. Sketchy demo. So a little bit about what's next and a slight summary. MIDI is still hard to implement. To do MPE, you have to support MIDI properly. You have to be aware of registered parameter numbers. You have to handle control data properly. You have to make sure that you're supporting things like all notes off and all sounds off, and you have to just sort of tidy up your MIDI implementation a lot. That's true of all people, but it's especially true when you're writing a DAW because of two reasons. Firstly, you have to be aware of MPE when you're note editing, so you can encapsulate all this control data happening on a channel and keep it attached to the note, so that when you move a note or you delete a note, that stuff moves with it or is deleted with it. Another thing that you need to do if you're writing a DAW, and this is a real pain for everybody who is, DAWs or sequencers, imagine if you're writing an arpeggiator or looper and you want to move the start point. All the control data kind of has to stay where it is, but the start point, the note on has to move. And there's this, you need to be contextually aware of what you're doing to the MIDI stream all of a sudden. And you have to be aware of it from an MPE point of view. If you haven't done it already, your note model has to sort of change, so that instead of having a channel note MIDI stream looks the same model, you need one where you say, this note, you have a note which is an event in space-time. The channel's not important. What's important is that all the control data that happened in that note is bound to it. You can reallocate it to another channel when you play it out, and the channel state is not important in MPE, and we've told people not to do anything about the absolute channel number. So you peel the channel stuff away, and you've just got this string of data that and if you move the start point, the data stays, start point moves. And it's just, it's a complete change of note model. Not everybody is ready for it, so it's really hard if you're doing a DAW just to add MPE support. It's take you a little while to build it in, depending on how nice your code already is. Design decisions. So one of the ones that the blocks teams head in recently was controller number 74Y is mandated as having to give away absolute position in MPE, because this is 0, this here is 127, this here is 64. And from absolute you can usually interpolate relative, except when you can't. And note editing makes that kind of thing particularly difficult, because if you played a note here and you moved it down here, and suddenly you want to move the start of the note to that part, what do you do? If you've got relative or absolute, how do you recompute things? And sort of edge cases like that gave them headaches. And so those design decisions still, they've been resolved, but they sort of need codifying a little harder. Oh, and just MIDI being neither stateful nor stateless. The way that MIDI works, you tend to be dropped into a stream halfway through stuff happening, and you just have to make sense of it. It tries to be stateless, but you have things like registered parameter numbers where you're sending 4 separate messages to convey one piece of information. But the whole MPE is a kind of sticking plaster over MIDI. There are things that should be coming that make this dramatically easier to sort out. And that's the subject of my next slide. HD will save us. HD is a draft specification that the committee, the MIDI Manufacturers Association, have been working on for somewhat over a decade now. It has good things about it. first. Notes are truly stateful events, so you have a note happening, a note in its decay state, a note that's reset and doesn't exist anymore, and a note that's idle and waiting for input. So they sorted that state of model out properly so that when you take your finger off a note and it's in the release phase, things can be aware of it, and the communication is bidirectional, so it's a much friendlier way of dealing with things. One of the limitations of MPE, by the way, is when you stop a note, you can't control it anymore, because that information might be needed to be attached to the next note. So note off event means stop controlling this note. If you have things like auto-tune going on where your finger is being pulled to a semitone slowly, and you take your finger off the note, that stuff has to stop happening even though the decay tail may last another 5 seconds. It's one of the limitations. It's a bit of a pain, but if we came up with a more elaborate solution, it would just break something further down the line. So we just keep the failure mode simple, and users are aware of when they will happen. Parameters are parts of events, as they are in MPE. So controller messages are latched to notes, which are events, and they're not latched to channels, which are not events. They're just kind of streams, and that's how things should be again. And there's a global event for things like sustain pedals or burning the house down. You can control a note after it's turned off, which you can't do, as I've just explained with MPE. Can you tell this is under rehearsed? MIDI actually spoils us. One of the reasons why HD hasn't saved us yet is because MIDI is truly everywhere. We've had 33 years to make it a household name, and it has become one. It's really, really easy to implement. It's the easiest USB protocol in the world to implement, because every operating system supports it fairly well. It really spoils us in that sense. The convenience and the ubiquity of MIDI means it's quite a hard thing to displace. And it does work for most people most of the time, which is, it's not what you really ideally want from a spec, but it's good enough. There's a lot of HD, and it's quite onerous. The spec document is it's over 200 pages now, I think, and it looks nothing like MIDI. There's all kinds of session layers, and the transport protocol can be USB, or it can be MIDI, or it can be UDP. How you implement it is something of a running question, and it's a lot to bite off at once. So, oh lordy, trouble so hard. Diplomatically, it's become quite a hard sell, because usually the way you write a specification isn't spending 10 years in isolation as a committee and then bringing it out into the world and going, do you want this? And then they go, you've produced 200 pages of stuff, and I'm quite happy with MIDI. So those things might be resolved in the near future, but it's going to take some severe strategic wrangling, and we probably won't see it in the wild anytime soon, except as a draft spec. And maybe what will happen is it'll just end up meeting the world as a draft specification, because the ratification process is just too long and too political, and the use case for it won't exist until the products are out there. So we'll see what happens. But HD may one day save us, who knows? So the moral of this is that as ROLI, we couldn't do much on our own. If you want the industry to take notice, maybe if you've got 15 companies all working together, you can achieve some consensus, and that's why we're now able to insinuate ourselves into some of these synthesizers and the wider world, and companies like Apple and Bitwig, and maybe one day, who knows, no promises, terms and conditions don't apply, Ableton. And I will leave you with that thought and a picture of a piñata, because I have just come back from Mexico, and thank you very much.